Now you can ignore all this stuff in yellow over here. Ran out of board space and had to use some of this in our physics lab. But the white writing from here on up to here is what's relevant to our class. So we have an expression that says log of 4 plus a log of 25 equals what? Well, let me write it down here. First of all, log of m times n equals a log of m plus the log of n. Okay, well, what we have here is a log of something plus the log of something else. And this says that if you have the sum of two logs, it becomes a log of the product, doesn't it? Sum of the logs is the log of the product. So, log of x plus a log of q must be the log of x times q, right? Okay, because log of m plus log of n equals log of m times n. Now we could rewrite this equality backwards, but we don't need to do that. We can turn it around in our head. Okay, so what's the log of 4 plus the log of 25? Well, it's a log of 4 times 25 by this rule. Log of m plus log of n equals log of m times n. And 4 times 25 is 100, so this is a log of 100. And you know, if you were paying attention in our preceding class, that the log of 100 is 2. Remember, log means log to the base 10, and if you make a table of 10 to the x, which is the inverse of the log table, when x equals 2, 10 to the x is 10 to the second power, which is 100. So we know that the log of 100 is 2. And we should know the log of 1 followed by any number of zeros, or preceded by a point, 0, and any number of zeros. Those are our powers of 10. So we should understand our powers of 10, so we always know what the log is. And your calculator, of course, has an log button, but you're forbidden to use it to do a power function, to do a power of 10. If it's a log of anything but a power of 10, you have to use it. If it's a log of a power of 10, a whole number power of 10, or an integer power of 10, because you could have a negative power, don't be using the buttons. Or if you do use the buttons, you better have an explanation in your paper that tells me why the log is what it is. Now, if it's a number that isn't a power of 10, an integer power of 10, you have no good way of calculating that, no good way of understanding why the log is exactly what it is, so you can use the calculator, unless you're otherwise instructed. Okay. Another alternative, of course, is to make a good graph of the log function, just by making a graph of the corresponding exponential function and reversing the coordinates and make estimates. Okay. Well, now, another thing we have the equation, and I didn't originally thought I had more equations than this, but I don't. Okay. Well, we can say that the log of 10 raised to the 4x minus 9 is what? It is 4x minus 9. The log of 10 to anything is that anything, because the log x and the 10 to the x function are inverse functions, as we explored in our first class dealing with logarithmic functions. Okay? And that's useful in solving exponential equations. We did solve a couple in our preceding class, and it's just a preview. We're going to be solving more. So just so you have your money's worth out of watching this, let me solve one. Okay? Let's say we have then the equation 10 to the 4x minus 9 equals 7. Okay? How are you going to solve that equation? Well, you might try all kinds of things, and you're probably going to be tempted to try a lot of things that aren't valid. We can't multiply 10 to the 4x minus 9 by anything, or divide it by anything to isolate the x. There's nothing we can do as far as multiplying, dividing, adding, subtracting quantities to both sides. The only thing we can do to both sides is we can take the log of both sides. So we can take the log of 10 to the 4x minus 9, and of course that's equal to the log of 7. Now the log of 10 to the 4x minus 9 by the inverse function property is just 4x minus 9. And that's equal to log 7. We can add 9 to both sides. We get 4x equals log 7 plus 9. And then we can divide by 4. We get x equals log 7 plus 9 over 4. And I'm going to put parentheses around the log of 7 so you're not tempted to add the 7 to the 9, because adding log 7 to 9 is not like the log of 7 plus 9. That's totally invalid. You're not doing anything involving a log of 9. Now, 9 is not subject to the log function. And when you get x equals log 7 plus 9 divided by 4, you got the LOG button on your calculator, and you can get a solution. You could estimate a solution. You could estimate the log 7. Okay, estimate the log 7 by making your graph of the log and labeling it carefully. You can see that the log of 7 is fairly close to 1. It's between 0 and 1. Your graph would show you that clearly. So you might estimate, okay, log of 7 looks like about 0.8. So maybe that's 0.8 plus 9, 9.8 divided by 4. Okay? Maybe it's 0.9, maybe it's 9.9 divided by 4. You can get a pretty good estimate from a graph, but if you want a precise solution, you will go to your calculator. And you won't use your calculator to graph the log function, will you?